Okay, so this is a little bit complicated, so you'll definitely need the hints that I give you here. If you look, you have a right triangle that has a diameter as part of its hypotenuse there. So if this is 180, then that angle, that entire angle in that corner is 90. If this angle is 130, then that arc is 130 because it's a central angle. If that's 130, then that's 50 because it makes up that 180 diameter at the top. If that's 50, then that's 50 because that's a central angle that comes from that same arc. If this is now 50, then you can trace that all the way back to that inscribed angle, which would be 25. The next piece of the puzzle might be to look at this triangle right here. And you have an angle of 130, an angle of 25, and we know that that has to total 180 with that third angle x. So 130 and 25 is 155. So that leaves us an angle of 25 right there. Turned out it was isosceles. So we know that one now. Okay, now let's look at this 130. That's from here all the way to here. So if we look at this, where that 130 came from, this would be half, so that's 65. And now we know everything that it asked us to find. Alright, there are probably several ways to start a lot of these problems. You just have to take a stab at something and see if it works. The first thing that I saw were these two intersecting chords, and it gave me the angle, which is obviously here too, although you don't need it. And here are the two arcs on the outside that it's dealing with. Just like one of the problems we did in class today. One arc plus the other arc divided by 2 equals the angle in the middle. This is the average of the arcs, which one of them happens to be x this time. Whoops. Alright, so I'm going to solve this algebraically by clearing the 2. And I have x plus 85 equals 130. Subtract 85 from both sides. And I have 45 degrees for this arc out here. Now I know you can't do this, but I'm going to erase some of this and focus just on this 50-degree angle and show you that it opens up to this full arc here. So if this is 50, then this full arc out here would be 100. And we already know from here to here is 45, so this part must be 55, because 55 and 45 have to add up to 100. So the arc for y is 55. First thing I saw here was this arc of 40, so that means this inscribed angle is 20. Another thing that I noticed is I have a diameter here, which means this entire arc is 180. And if I have 80 here, that means I have 100 on that side. Now what jumped out at me was this 100 came from that y, which was 50. So now we know that y is 50. And now I know that this entire bottom half is 180. And if that's 40, then this is 140. So now z is 140. And the last thing I have in this problem is w up here. And w opens up to the diameter, which is 180. So w is 90. Here's an average problem again because it's two chords. So I have the average of this arc and this arc equals that angle. So I have 4x plus 8x divided by 2 equals the angle. So that's really 12x divided by 2 equals the angle, because 4x and 8x is 12x. Then I'm going to multiply both sides by 2 to clear the fraction. And 132 times 2 is 264. Divide both sides by 12, and x is 22. In this problem down here, it gives you 2 right angles in the middle, but that's really 4 right angles, right? So this arc has to be 90 because it's a central angle. This arc has to be 90 because it's a central angle. I mean, there's basically 4 90s here. This entire thing is 90. The one piece of information that it did give you over here was that ED, that arc is 50. So if that's 50 and this whole thing is 90, then that's got to be 40 because 50 and 40 make 90. Let's see if I've answered any of these questions yet. Arc AB. Arc AB is right here. That's 90. Arc DC is right there. So that's 40. Arc EA, we have that done as well. Angle AFB. This is a little bit interesting. Angle AFB is this, either of those 2 angles there. It's actually this one, but it's those 2. Those angles come from these 2 arcs. So it's the average of those 2 arcs. So you set up one arc plus the other arc divided by 2, and that's your answer for that. Angle DAC is going to be half of 40 because it gets pulled all the way back to the corner up here. So half of 40 goes here. Okay, so on this next page, you have the exterior angles. And if you look at your notes from Monday on the first page of the packet, when the angle is outside, you have 2 secants, or sometimes a secant and a tangent, or even sometimes 2 tangents. It's all the same thing. The angle's on the outside. So you take the big arc that's intercepted, take away the small arc that's intercepted, and divide by 2, and you get the angle. Same thing here. You take the big arc that's intercepted minus the small arc that's intercepted and divide by 2, and you get the angle. That's 2 tangents, but it's the same problem. Here, it's the same idea. There's 2 arcs intercepted, this one and this one. Now, I'm not going to do this for you, but a whole circle is 360. This 110 isn't really part of the problem, but you need it to find that arc first, because a whole circle is 360. So you have to take away 110 and 80 to find out what this is. Then it's this one minus this one divided by 2. Here, the algebra is just a little bit differently. Here it's the big one minus the small one divided by 2 equals the angle. So a little bit of algebra, clearing the 2 will set you up nicely for that one. X minus 48 equals 64. Take it from there. This one only gives you one number. So you're like, how do you solve this one? Well, a whole circle is 360. It's 2 tangents, so there's no missing part. Those 2 arcs make up the whole circle because of the fact that it's 2 tangents. So you just say, well, 360 minus 254 is 106. So that one's 106. Then you do the big arc minus the small arc divided by 2, and that gives you your angle. Okay. Number 6, same idea. Big arc minus the small arc divided by 2 equals 2x. So a little bit of algebra to do at the end there because you have a 2. It's not just an x. And that's it. See you tomorrow.